In this video, we're going to look at unit vectors and direction angles. So a unit vector is simply a vector of length 1 unit in the same direction as the given angle. So if v is not the zero vector cannot have a unit vector because remember the zero vector has no direction. So we cannot create a vector that has the same direction as the zero vector since it does not have direction. So then let's say we're going to create the unit vector for vector v. So we're going to say vector v is v1, v2. So to find the unit vector, you essentially just take the two components, the horizontal and vertical components, and you divide them by the magnitude. So my unit vector would really just be my horizontal component divided by the magnitude, and then the vertical component divided by the magnitude. So in order to find a unit vector, really you have two steps, and that would be to first find the magnitude, then divide both the horizontal and the vertical component by that magnitude. So let's take a look at an example here. We want to find the unit vector in the direction of vector v, which is the component given in component form -3, 2. So if we just kind of visualize this vector for a minute, this would be the vector -3, 2. So what we want to do is come up with a vector along that same directed line segment that has a length of 1. So the first thing that we need to do is find the magnitude of v. So since we have component form, we just have to do the horizontal component squared plus the vertical component squared. So this is going to be 9 plus 4, which is going to give us the square root of 13. So once I do that, then I just need to take, to get my unit vector, I'm going to take each of the components and divide by the magnitude. So my unit vector will just be -3 over radical 13 and 2 over radical 13. All right, so the next thing we want to talk about are direction angles. So the direction angle, remember, is the rotation from the positive x-axis to the vector. So my direction angle over here is represented by theta. So if we know the magnitude and the direction angle of a vector, then I can find the horizontal and vertical components by using just some trigonometry here. So my horizontal component would be this red segment here. That's now purple. And in order to find that, we would take the magnitude of that vector times the cosine of theta, because remember the cosine value is your horizontal component. And then the vertical component, which is now the orange vector here, is going to be the magnitude of v times the sine of theta. So just using our trigonometry back to chapter 4 and chapter 5, cosine is the horizontal component, sine is the vertical component. So if you're asked to resolve a vector, it just means that you want to find these two components and then write it in its component form. So if we write it in the component form, it would just be magnitude of v cosine of theta and then magnitude of v sine of theta. So again, we want to find the component form of vector v. It has direction angle 115 degrees and magnitude of 6. So in order to find those components, we're going to take the magnitude, which is 6, times the cosine of 115, and then the magnitude, which is 6, times the sine of 115. So we can get these approximate values using your calculator. Remember to check your mode. So in this case, we want to make sure that we're in degree mode, and then we're going to do 6 cosine 115, and then 6 sine 115. So then we can say v is approximately -2.54 and 5.44. If I want to find the direction angle from the component form, then we have to do a little bit of work, and we have to remember a lot of things about our angles of rotation from the coordinate plane. So first thing that we're going to do is plot the vector to determine what quadrant we're in. So just kind of plot out your vector. Then we're going to find the magnitudes. Remember, the magnitude of v is going to be the square root of a squared plus b squared. Next, we're going to use the horizontal component and set it equal to the formula. So we're just going to take our horizontal component, which is A, and we're going to take whatever that A value is, and we're going to set it equal to the magnitude of the vector times the cosine of theta. We could also use the vertical component, but using sine causes a few more problems if we're not in the correct quadrant. With cosine, it's a little bit easier, so we'll just go with that. Then we're going to solve for theta, so we would just solve to get theta by itself here, which, remember, is going to require us to use like inverse cosine here. So in order to do that, we're going to use cosine inverse. Then remember, we're going to go back and we're going to remember what quadrant we should be in. If theta's in the appropriate quadrant, then we're okay. If it's not in the appropriate quadrant, then we need to do a little bit of work. So here we're going to find the magnitude and direction angle of this vector here. So remember, the first thing I'm going to do is figure out what quadrant I'm in. So if this is the vector 3, -2, then I would be here. So I'm in quadrant 4. So then the next thing I want to do is find my magnitude. So the magnitude of V is going to be 3 squared plus -2 squared, which is going to give me 9 plus 4, which is the square root of 13. So then remember, next I'm going to take my horizontal component, which is 3, and I'm going to set that equal to magnitude 3. I'm going to set that equal to magnitude times the cosine of theta. So I know my magnitude is the square root of 13 times the cosine of theta. So I'm going to divide both sides by 13, or square root 13 here. And then to get theta by itself, we're going to do inverse cosine. So theta is inverse cosine of 3 over radical 13, which gives me theta is about 33.7 degrees. So a rotation of 33.7 degrees would be up here, and obviously that's not where my vector is. So what we have to remember is that the cosine of an angle and the cosine of the negative of that angle are the same. So what we can use instead for this angle is negative 33.7 degrees. Is negative 33.7 degrees. Now a lot of times they will tell you that theta has to be between 0 and 360. So if theta must be between 0 degrees and 360 degrees, then we just want to find an angle that's coterminal to this. So remember, my coterminal angle would be this angle, and in order to get a coterminal angle, I'm just going to add or subtract a whole circle. So theta is negative 33.7 plus 360. So theta gives me 326.3 degrees. So both this angle and this angle are correct values for theta. It just depends on if there were any restrictions given in your directions as far as the angle goes. And just one more example of finding the direction angle here. So one more example of finding direction angle here. Again, we're going to plot this vector. So I've got -2, -5. So my vector is here. So my vector is in quadrant 3. So again, the first thing I'm going to do is find the magnitude. So we have the square root of -2 squared plus -5 squared, which is going to give me 4 plus 25, which will give me the square root of 29. Then again, we're going to take the horizontal component, -2, equals the magnitude times the cosine of theta. Divide both sides by the magnitude, and then we're going to get theta is inverse cosine of -2 over the square root of 29. So theta is 111.8 degrees. Again, if I come over here and I look at where 108 or 111.8 degrees would be, it would take me into quadrant 2, but my angle is not in, or my vector is not in quadrant 2, my vector is in quadrant 3. So I have to do this rotation instead, which is going to be the negative 111.8 degrees. So theta is negative 111.8 degrees. Again, if theta is restricted to be between 0 and 360 degrees, and we have a negative rotation here, we're just going to add a whole circle. So negative 111.8 plus 360. So theta is 248.2 degrees. And again, remember, both of these are correct answers for theta. They're both rotations that would get me into quadrant 3. So it just depends on any restrictions. If there's no restrictions given on theta, you can give the negative 111.8. If you're restricted to theta has to be between 0 and 360, then you would need to do the 248.2 degrees.